Look at this mess. We've got water, raw sand, and jagged salt crystals, all being vigorously stirred together in a single beaker. When you combine different substances like this, you create a mixture. The ingredients are sharing the exact same space, but they aren't permanently changing their chemical identities. Since the sand stays chunky and visible, this is an uneven, heterogeneous mixture, basically a combination where the parts don't actually blend. Because those heavy particles sink to the bottom if left alone, we call this a suspension. This view shows the salt behaving differently. Its particles break apart and spread out so perfectly that they disappear. This creates a homogeneous mixture, a uniform solution where the salt and water are perfectly blended together. These perfectly blended mixtures exist as solid objects too. If you view a gold ring or a bronze statue, you're actually seeing an alloy, different metals melted together so evenly you can't see where one ends and another begins. So here is our puzzle. Since we can't just reach in and pick microscopic salt crystals out by hand, we have to use the unique physical rules of these materials to unmix them. We actually took our first step towards solving this puzzle the moment we stirred the beaker. We used a method called dissolving, taking advantage of the fact that salt easily melts away into water, while sand does not. Because the sand is just a suspension, we can let gravity do the heavy lifting. If we leave the beaker alone for a few minutes, the sand naturally settles right to the bottom. Now we can carefully pour the liquid into a new container. This act of decanting leaves the heavy sand behind, separated from the group. Just like that, the first component of our puzzle, the sand, is isolated. By leaning on a simple physical difference, the fact that some things dissolve and others don't, we easily tackled the messy, uneven part of our mixture. But now we face a much harder problem. We are left with a saltwater solution, and it perfectly hides its ingredients. If we left this water in the hot sun, the liquid would slowly turn into a gas and float away. This is evaporation, and it would eventually leave a nice crust of pure salt behind. The problem is that the water is lost to the air. To fully solve our unmixing puzzle, we need to capture that water, not let it disappear. This distillation setup rescues both salt and water. As water in the boiling flask heats, it turns to steam, leaving solid salt below. The hot steam travels into the cooling tube, condensing back into pure liquid drops that collect steadily in our secondary flask. Distillation lets us pull apart perfectly blended solutions by exploiting the different temperatures at which these ingredients turn into gas. Some mixtures, like milk or blood, don't boil quite so easily. We need different physical forces to pull them apart. If you tie a pencil to a string and spin it, you feel it pulling outward, away from your hand. That is centrifugal force. Laboratories use machines called centrifuges to apply that same force. By spinning liquids at extreme speeds, heavier components of a mixture are forced to the bottom, while the lighter parts float to the top. We can also use crystallization to pull pure solids out of a liquid that is already holding as much dissolved material as it possibly can. When you cool down a saturated solution, a liquid packed with dissolved solids, the material is forced out, growing into sharp, geometric crystals. Even when a perfectly blended mixture fools our eyes, physical forces like gravity, motion, and temperature can always force those ingredients back apart. Let's look at what we've done. Starting from one messy beaker, we have systematically extracted a pile of dry sand, a layer of dry salt, and a flask of perfectly pure water. Because the ingredients in a mixture are only physically sharing space, we can always use their unique traits, like how they boil or whether they dissolve, to pull them back apart. So here is a challenge for you. Imagine you accidentally drop a handful of magnetic iron filings right into a bucket of dry beach sand. Which physical trait could you use to separate them? Or what simple tool from your garage would you use to quickly pull all that iron back out? Drop your answers in the comments below. While you're there, hit the like and subscribe buttons, and keep thinking like a modern chemist until the next video.